Hello, and welcome to the first in a series presenting an overview of the back-lattice exterior wall assembly. This is David Schoenhardt, the architect, inventor, and president of Back-Lattice Wall Systems. My 40 years as an architect, designing and detailing commercial buildings, and then my last 5 specializing in the building enclosure, led me to the comparative study of 8 commercial walls. The 8th of these, referred to as back-lattice, has remarkably taken off on its own and become an innovative and test-proven high-performance wall assembly. Let's start by clarifying that the back-lattice wall assembly is not a constructed thing. It is not an object. It is, however, a patent-pending wall assembly method or system. It is a way of assembling a high-performance exterior steel stud commercial wall using open-sourced materials. As an overview of the topics in this presentation, we will be covering 8 aspects of back-lattice, or its abbreviation BKL. First, we will describe what is back-lattice. Then we will compare other wall systems to back-lattice. Then we will describe the wall's 6 primary components. We will next review a variety of benefits to back-lattice. Then we will describe how back-lattice is an open-sourced system composed of a variety of available high-quality materials. Next, we will describe the specialized sub-girt components that Back-Lattice has branded and arranged national manufacturing and distribution. Then we will describe Back-Lattice's rigorous performance testing. Finally, we will review the Back-Lattice project registration, fee, and warranty. Let's begin by describing Back-Lattice. It is an integrated wall assembly located inward of the protected sheathing. It is a comprehensive, compact assembly that is unique, innovative, and patent pending. It always helps to provide a concise definition to a new idea that is unique. The back-lattice panel is a fire and thermally proven high-performance wall assembly with thermally broken horizontal sub-girts located inward of the protected sheathing and then back spray insulated. This leaves a naked panel exterior that only requires final cladding. Let's learn more by comparing other wall assembly arrangements to back-lattice. Instead of a wall with exterior mineral wool insulation that can become wet with rain screen back cavity drainage and summertime condensation, instead of that wall, which then loses its insulation value as long as it is wet, but then also slowly collects atmospheric dirt buildup, which then holds the moisture even longer. Back-lattice, however, provides a protected, continuous, and total insulation located inward of the air and weather barrier protected sheathing, where it is permanently dry. So that we don't offend the mineral wool fans, Back-lattice also loves mineral wool. It's just back in the wall cavity where it is kept dry. Likewise, back-lattice does not like spray foam on the exterior side of the sheathing where it can get wet, shrink, and crack. The back-lattice components are kept inward of the protected sheathing. Instead of outwardly located, inefficient, horizontal galvanized steel sub-girts that act as thermal brakes, instead of each outward horizontal sub-girt acting as a mini water collecting shelf, or instead of a vertical sub-girt arrangement that requires extensive coordination to align with the vertical studs and wastes energy with through fastening, Back-Lattice, however, places thermally broken horizontal sub-girts inward of the protected sheathing. This presents what is called a naked exterior that is free of outward sub-girts and outward continuous insulation, and free of coordinating atop the vertical studs. Next, we will review the 6 primary components that compose the back-lattice wall assembly. As an overview, we will first discuss the air and weather barrier protected sheathing. Next, the horizontal back furring. Then, the thermal break isolation pads. Next, the vertical structural studs. Then, the back spray foam insulation. And then finally, as an option, we will discuss the fibrous mineral wool batts meant as additional super insulation and or 2-hour fire protection. The first of the 6 primary components is the air and weather barrier, or AWB protected glass mat gypsum sheathing, which forms the outward layer of the back-lattice assembly. Upon what is referred to as this naked exterior is applied to the cladding and its support tracks, which leaves a rain screen, air vent, and back drainage cavity. 5/8" gypsum sheathing is required due to the NFPA 285 assembly certification because of gypsum's important role in protecting the back sprayed foam insulation. The AWB, an acronym which is often substituted with the easier to say but inaccurate AVB, is intentionally and importantly vapor permeable, with a perm rating of over 10. This allows any residual moisture in the sheathing layer to re-vaporize and dry out. The AWB, as code required on the sheathing, is Class A with a flame spread of less than 25 and smoke developed of less than 450. The AWB may be either pre-applied to the sheathing board, or it may be fluid applied, or it may be a self-adhering membrane that is applied to the sheathing. Back-Lattice does not recommend a mechanically fastened sheet AWB membrane because its air flutter behind the membrane can present unwanted condensation risks. Next are 3 of the 6 primary components. The shallow 1-inch deep galvanized steel Z-Back brand horizontal back bearing is manufactured by Clark-Dietrich for BKL, accepts the horizontally fastened outward sheathing. The back furring rests on 1/2-inch thick, high-density urethane thermal isolation pads at each furring to stud intersection. The T-Pad brand isolation pads, as made by Armatherm for BKL, and function as R1.55 thermal breaks, are better than the ASHRAE standard. The long version of the pads are 2-inch wide by 8-foot long strips applied continuously to the fronts of 2-inch wide vertical studs. The short version is the same, except the 8-foot long strips are cross-scored to snap break into individual 6-inch long short pads. Each furring to stud intersection is separated by a thermal isolation pad and fastened with a single number 12 hex washer self-drilling fastener to the structurally designed steel studs. Next, we will describe the assembly's two insulation components. The typical insulation for all back-lattice assemblies is 3 5/8 inch R24 closed cell 2-pound density spray urethane foam with a flame spread of less than 25 and a smoke developed of less than 450. This is back sprayed to the sheathing, which encapsulates the back furring and isolates the outward stud flange from the sheathing. The 1.5 inch sheathing to stud offset gap provides for an R10 of continuous insulation that is uninterrupted as it weaves outward of the stud and inward of the back furring. The remaining of the total R24 is considered between stud insulation to fully comply with the prescriptive R-value energy requirement. The closed cell foam also functions as an additional air barrier, a bidirectional Class II vapor retarder, and it adds structural resiliency due to the three-dimensional structural crisscross back framing. When the wall assembly requires a 2-hour fire rating, or when the wall requires it to be R39 super insulated, then a sixth component of 3 1/2 inch R15 2-pound density unfaced mineral wool batt insulation is friction fit between the studs and tucked into the steel flanges. BKL has hygrothermically modeled and confirmed that this batt insulation does not inadvertently trap condensation moisture. The next section of this overview presentation of back-lattice will focus on the benefits of back-lattice. This will include a discussion of its fire safety, then its naked exterior, next its construction efficiency, then its high performance characteristics, and then finally its qualifications of sustainability. Back-Lattice has worked with Intertek to perform ASTM E119 fire testing to confirm that Back-Lattice can meet a range of firewall assembly ratings that have load-bearing capacity. 2 hour 80% load bearing from the interior has been proven, while 1 hour 100% load bearing from both the interior and exterior have also been test proven. Priest & Associates has validated that Back-Lattice complies with NFPA 285 vertical and horizontal fire propagation requirements, as well as lateral fire stopping within the cavity space. As described earlier, the Back-Lattice wall assembly presents as what is referred to as a naked exterior atop the AWB protected sheathing. This means there is no traditional exterior mineral wool continuous insulation or exterior sub-girt framing. This results in fewer outward components. Only the final flashing of the panels, as well as the application of the finished cladding, is required. Fewer components means faster exterior construction, and fewer components means better quality control. Back-Lattice recommends a 12-month exposure-rated air and weather barrier to allow sufficient time needed to install the final cladding when the construction schedule is ready and the weather cooperates. With fewer outward components, construction efficiency is improved. Back-lattice with its complete wall assembly inward of the sheathing is less weather dependent. The fewer outward components results in a faster installation because the assembly is readily prefabricated or panelized. The panels may ship complete, or the spray foam may be applied on site to the weather-protected interior. Some cladding systems may also be pre-applied. Back-lattice is a carpentry and spray foam solution to an integrated prefabricated wall assembly. Back-lattice is a test-proven high-performance wall assembly. Three-dimensional thermal modeling has validated its true ASHRAE and U-factor high-performance values. WUFI hygrothermic modeling, which is taken over 3 years in climate zones 2A, which is Houston, up to 6A, which is Green Bay, has proven back-lattice and its super insulated option perform safely without condensation buildup in all 4 seasons. Back-lattice is also considered high performance because all its fasteners are incremental without through fasteners to waste energy. Back-lattice's proven high-performance wall assembly is aided by the spray foam's capacity to provide a bidirectional Class II vapor retarder from both the exterior and interior without creating a vapor trap. Prescriptively, the wall exceeds the energy code requirements with R10 of continuous insulation plus R14 of between stud insulation. Alternatively, code-compliant thermal modeling has proven its total wall assembly of U0.063, which is better than code. The thermal isolation break of R1.55 more than complies with ASHRAE. Additionally, should the assembly choose to super insulate, this can be accomplished to R39 prescriptively, or an assembly factor of U0.050 without the risks of any inadvertent condensation or moisture harboring. Because the back-lattice assembly is so thermally efficient and can be safely super insulated, it complies with net zero energy initiatives. Passive house is accomplished with this super insulation. Back-lattice is registered as an ABAA licensed supplier, so that should the project be ABAA required, the back-lattice assembly will comply. Back-lattice has initiated coordination with lead EPDs and HPDs to aid in its assembly of compliance points. Along with the exterior cladding and the interior wall finish components, the total assembly approaches the required 10 for each. The urethane spray foam is the newest generation of HFO blowing agents with a less than 1 GWP global warming potential. This results in the BASF Wall-Tite being Green Guard Gold certified. From the beginning of back-lattice, supportive relationships with multiple manufacturers continues as an open-sourced solution. This means back-lattice is an assembly method that accommodates a variety of high-quality materials that are chosen by the design professional, government specification, the panel fabricator, or by regional preference. Materials must comply with the broad descriptions with Back-Lattice's NFPA 285. Open-sourced materials also accommodate competitive bidding, which is accomplished between multiple back-lattice authorized fabricators and between competitive material choices. Just the sub-girt furring and thermal isolators are accessory, unique, and required in order to preserve the BKL warranty. Back-Lattice utilizes a specialized sub-girt assembly of shallow 1-inch deep back furring and 1/2-inch thick thermal isolation pads. These items are unique enough that Back-Lattice has assembled them into Back-Lattice branded products. The Z-back is the typical field back furring. The J-back is used for the top and bottom horizontal edges, and L-back is used for vertical edges. They are manufactured by Clark-Dietrich for BKL and available through authorized distributors. These branded products are also available for purchase on non-Back-Lattice projects. BKL's nominal markup is included within the distributor's unit price. Continuing with the next sub-girt specialized accessory component, the Back-Lattice T-pad thermal isolation pads in both their long and short versions are manufactured by Armatherm for BKL and distributed directly by Armatherm. Back-Lattice includes a nominal markup within the unit price. These branded products are also available for purchase on non-Back-Lattice projects. Back-Lattice takes its mission of protecting safety and the environment so seriously that it performs continued performance testing each and every year. To date, as stated earlier, NFPA 285 engineering evaluation and E119 fire-rated assemblies have been test proven. Full-size mock-ups have also been tested for water and air leakage. Thermal and hygrothermal analysis have proven its performance in multiple climate zones. Even when a fire assembly testing fails, it then informs the design for critical improvements. Back-Lattice is unique as a wall assembly and not as a thing. The project registration begins with listing the project with a registration fee per square foot of panel area. In return for the project registration, Back-Lattice provides design and submittal phase guidance, quality control validation, archiving, and system warranty. Back-Lattice provides customized guidance during the design and submittal phases. Back-Lattice provides knowledgeable architectural and structural engineering guidance along with the BKL localized sales reps and authorized fabricators to assist with assembling a viable and efficient Back-Lattice project. Back-Lattice provides review of the BKL authorized fabricators' shop drawings in order to validate the quality control of the BKL wall assembly during the design and submittal phase. On each Back-Lattice registered project, quality control is required, implemented, and validated from multiple directions. BKL is compliant with ISO 9002 standards, including declaration of quality by management, documentation of the process and required paper trail, which includes compliance inspections. Back-Lattice utilizes ASTM testing standards. Back-Lattice maintains their assembly design quality control by continuing their yearly product development testing. The quality of the fabricated panels is assured by a network of BKL authorized fabricators that each maintains a required continuing education program for Back-Lattice and current lessons learned. Back-Lattice also requires each authorized fabricator to perform a set of protocol minimum quality control testing and archiving, to which BKL performs routine validation. As well, Back-Lattice encourages and welcomes other and additional third-party testing, ABAA, and enclosure commissioning. To complete the BKL quality control program, Back-Lattice and their authorized fabricators maintains a long-term archival system for every registered project. Warranties provide the assurances that Back-Lattice, the authorized fabricators, and the open-sourced materials utilized are meeting the project's expectations. Each Back-Lattice authorized fabricator provides their own 1 or 2 year warranty. Each installed material maintains their own product warranty. Back-Lattice additionally provides a 5-year system warranty for each registered project. Back-Lattice stands behind their wall system design, their customized guidance, and their quality control program. This concludes our overview of the Back-Lattice wall assembly. What started as a comparative study of 8 commercial walls has turned into an invention of a unique and test-proven high-performance wall assembly that has taken on a life of its own. Back-Lattice is so innovative in how it places the primary wall performance components inward of the sheathing that we say Back-Lattice is back fusion for the exterior wall. Back-Lattice moves the horizontal sub-girt framing and thermal isolators inward such that the exterior sheathing is attached to the horizontal backburring instead of to the vertical studs. We say that Back-Lattice turns the wall on its side. So, until our next presentation, thanks for joining us.